sub blocks in the satellite. This is your bathtub curve showing the probability of a failure. Okay, so this is showing what is the probability of the failure of any sub block. Okay, initially you will see that when we are making it on, during that time probability of failure is much more. Okay, this is called your burn in time. That is called your burn in time. So this is the initially whenever we are giving the electrical energy, during that time it may be possible that as we are providing the energy, all of a sudden sub block or some of the part may not be working properly. There the probability of failure will be there. Okay, once they have started working, then you will see that the probability of failure it will become constant. Okay, initially you are having the high probability of failure, and with respect to time you will see that you will have the probability of failure constant, and this will be continuing with respect to time. And at the latter stage you will see that this is the end of the life. Here also you will find the increased probability of failure. So if you are seeing this your bathtub curve, in the beginning and in the end the probability of failure will be more. Okay, three more components. Okay, so what is the reliability mathematically? Reliability is the ratio of a number of surviving components after time t. Okay, so what we have done, you are having the sub block. Okay, there we have given the electric power, and now that sub block is working. So after some time, how many surviving components are there? So it is the ratio of number of surviving components after time t by total number of components before the starting time. So before giving the initial power, what was the total number of components and how many surviving components are there after time t? Okay, that ratio it is called your reliability. Okay, so that is your reliability. If number of surviving components are more, then we can rely on that subsystem. We can rely on that block. Okay, so it depends upon how many surviving components are there. Okay, we can go for reverse of that one. Means the number of failure components. How many components that are failed to perform? So number of failure components will be total number of components minus number of surviving components. So it is very simple. Okay, so total number of components minus surviving components, that will be the number of failure components. One more parameter is there, that is your mean time before failure. Mean time before failure. So whenever we are going for some sub-block, we should know that what is the mean time. So mean time you can consider it as the average time. Okay, and you should try to make this mean time greater than the life of the satellite. Okay. Ideally, you should try to make this mean time greater than the life of the satellite. So if the life of the satellite is over, after that if the failure is there in some sub-block, it doesn't matter much. Okay? So your mean time before failure, it is denoted as your small m, and it is your 1 by n naught. This is your total number of components. Sigma I t at the base I. So here I, it is starting from 1 to n. Okay. So at the time I, how many numbers of components that will survive? Okay, at time. So here we are taking the summation of this time. It may be possible that at time t1 some failure will be there, at time t2 some more failure will be there. So that we are continuing till time ti. Okay, so if we are considering that how many failures are there at different time interval, and if we take the summation of that one, we can find that what is the mean time before failure. Okay. The reverse of it is your average failure rate. Average failure rate, it is denoted as your lambda naught. This is your average failure rate. So what is the average failure rate? Average failure rate, it is the reverse of your mean time before failure. And what is this your average failure rate? It is the ratio of number of failed components by number of surviving components. So these are some of the parameters, some of the variables that we should know when we are discussing about the reliability of a system. Okay.